This Week in Virology, the podcast about viruses, the kind that make you sick. This Week in Virology, episode number 298, recorded on August 15th, 2014. Hi, everybody. I'm Vincent Racaniello, and you are listening to TWiV, the podcast all about viruses. Joining me today from Ann Arbor, Michigan, Kathy Spindler.
Hi, everybody.
How you doing out there?
Okay, beautiful days and pretty cool nights. This morning it was 6 Celsius, 43 Fahrenheit.
It's ridiculous.
I know.
It's like it's fall, but it'll come back. You know, this cycles. We have a little Indian summer all the time, right?
Yep.
Yeah, here it was chilly this morning, too. Now it's 23 C, partly cloudy. It's clouding up a bit, but it is a nice day. No humidity at all. 46% here. It's quite nice.
Yeah, it's 22 C here. Just perfect.
Also joining us today from Western Massachusetts, Alan Dove.
It is similarly lovely here. Good to be here.
Yesterday, Alan, I was talking to my daughter about where she wants to go to college. And she said, you know, I'm thinking about Bard. I said, okay, that's upstate New York. And then she said, there's some college in Western Massachusetts. And I said, Alan Dove. Because I'm so used to saying Alan Dove after Western.
Yes.
What is the college in Western Massachusetts?
Well, there are several of them, actually. There's Smith. There's UMass Amherst.
Mm-hmm.
There's, oh gosh, I'm blanking on some of the others. Mount Holyoke.
I bet it's Smith. I bet it's Smith.
Yeah, Smith is probably the most famous, although UMass is quite a good school too.
So I'll have to ask her tonight. Not Alan Dove University.
No,
right?
no, Alan Dove University is way too small an operation. We're not taking students.
Also joining us from North Central Florida, Rich Condit.
Howdy, everybody.
Bet it's 85 and 94% humidity there, right?
It is 83 and 77% humidity. That's 28 Celsius and mostly overcast, and we've had a whole ton of rain. And so, you know, it's been cooler than usual, not bad. My daughter went to Smith College.
Ah, right.
And the 5 colleges are Amherst, Hampshire, Mount Holyoke, Smith, and UMass Amherst.
There you go.
And they're all kind of in cahoots with each other.
That's the sister colleges they're called. Right?
Yeah, the 5-college consurtium.
Right.
Okay.
So there you go.
What's the reading on the Richter scale down there today, Rich?
The Richter scale?
Just kidding. You usually do everything else, so.
Yeah, well, you know.
Well, I'll see my daughter. Maybe she should go to North Central Florida University.
There you go.
That would be cool if she did, because then I could visit you.
That would be a good idea.
Nobody I know.
It's all good.
Of course, I could.
UF's a good place. Got a good library.
It does, apparently. Nice.
Yes.
All right, a couple of news items, and then we have a bunch of follow-up. Last week was a very popular episode. The WHO has published a document called Ethical Considerations for the Use of Unregistered Interventions for Ebola virus disease. And so I guess here it would include experimental therapies like the ZMapp monoclonal antibody cocktail that we talked about last time, or any vaccines that haven't yet gone into people, I suppose. And they give some guidelines about, you know, what they say. We think you can use it, but you have to follow certain guidelines. So it sounds like they're getting ready to allow people to start using other things that we talked about last week.
Of course,
they also talk about trying to gather as much data from such administrations as possible.
Right.
So,
which, of course, would be great, because you're sort of like doing a clinical trial, right?
Right.
Yeah. And I gather there's a supply problem with ZMapp at the moment.
Yeah.
Because nobody expected.
They're out.
Yeah, like they're out of it, because they hadn't really expected to be giving it to people at this point. So it was just a small batch experimental drug.
Yeah, they need to scale up.
Yeah.
The CDC has released its response to the anthrax and H5N1 incidents that we talked about a couple of TWiVs ago. You might want to take a look at that. The H5N1, they basically conclude that The transfer of unknowing transfer of H5N1 from one BSL-3 to another did not pose a safety risk. It probably happened due to failure of a laboratory scientist to adhere to established best practices and the absence of an approved laboratory team-specific protocol. And there was a lack of awareness and understanding about reporting requirements for these agents, which contributed to the delay in reporting the incident. And for the anthrax, they have a whole bunch of suggested things that they're going to undertake, including creation and appointment of a CDC Director of Laboratory Safety. And I understand that Alan Dove is in line for that position.
Yeah. No.
You wouldn't want it, right?
No, it's. I'm happy where I am. Thank you.
Touch it with a 10-foot pole.
No, have to move to Atlanta and also be
a director.
Be a director and be responsible the next time something like this happens.
Yeah. It's much easier to talk about it, right?
It's much easier to talk about it. Yes.
Head narc. I don't want to do that.
No, nobody would want to talk to you.
All right, let's do some follow-up. This first one from Mike came in while we were recording 297 last week. Hello, TWiV gang. Love the podcasts and videos that you have produced thus far. I'm currently an undergraduate in Nova Scotia, completing a double major in biochemistry, microbiology, and I'm really keen on virology. A microviral professor introduced me and the rest of my introductory micro class to the podcast last year, and I've been tuning in for every episode since. I love the lectures Vincent has provided online, as they have been a valuable resource as I prepare to enter a strenuous semester this coming fall. One of my favorite aspects of the show is your commentary on current events in the news, especially when talking about topics that the general public are perhaps misinformed about, i.e. needle CDC mishaps, MERS, etc. The most recent outbreak of Ebola certainly highlights just how much hysteria can be generated about a single topic, often because the media chooses to appeal to the viewer's sense of fear to increase ratings. I don't know if this would be considered a listener's pick, but I thought I would share an example of terrible coverage of this Ebola epidemic, and he provides a link to a website called Banouche, and he goes on, there's so much wrong with this article, which isn't surprising considering the source. Normally I would shrug off these articles as silly and move on. What bothers me, however, is that many folks online are turning to similar alternative news sources as a means of informing themselves on current events. I found this particular example making the rounds on Facebook, and many people seem to take it at face value. People repeat this misinformation frequently and even have developed ridiculous conspiracy theories about the origins of the virus. A question for Alan and Vincent. Do you find that the growing amount of alternative news websites poses a serious threat for reliable science journalism to communicate effectively online? Hopefully this email is coherent. Enjoy your summer, folks. Thanks for reading, Mike. P.S. Weather in Halifax, Nova Scotia is quite cool with a current afternoon temperature of 18 C and overcast skies that are set to give way to thunder showers. What do you think, Alan?
Well, it kind of cuts both ways. The websites like this, which is basically a clickbait site, from what I can tell, I hadn't seen Banouche before, but just scrolling through some of their regular articles, that seems to be their general business model. But this is unfortunate that people can spin out these wild theories by coming up with stuff that's either flat wrong, just outright lies, or complete, probably willful misinterpretations of the data. On the other hand, this type of thing is possible because of the internet that also makes TWiV and the virology blog that Vincent runs possible. So, you've got the good and the bad all wrapped up in there.
Yeah, I mean, it's hard because the web is huge and people put up whatever they want. And the model right now, as you say, one model is getting paid per click. So you try and get a lot of clicks and stuff spreads, and the real stuff kind of gets buried. So my blog, I have no clickbait. I mean, it doesn't make any money, and so we don't try and attract clicks. So it's hard. I don't know if it's a threat because the good science journalism is out there. It's just it gets swamped, right?
Yeah, I think the threat is people walling themselves off into their little echo chambers of their favorite conspiracy theories, which you can easily do now.
Yeah.
You can tailor your news. It used to be if you wanted the news, you could choose from maybe 3 radio channels and 3 TV channels in the evening paper. Now, if you want the news, you can get whatever stuff you want delivered to you in something that is custom cut for your preferences.
It's not really worth it for us to take each of these articles and write why it's wrong, right? Because we won't get as much attention as these articles do.
No, and there's a numbers problem. I mean, there are too many like this out there that we can't answer all that.
Yeah.
All we can do is present what is correct, and hope that people gravitate to that and say, hey, these folks actually have a clue.
And this article is very, very wrong. Many.
Oh, it's ridiculous.
And many wrong things.
And they pull in just random, Monsanto funded a company that's doing Ebola research, as if to imply that inherently makes something evil. Mm. So they just pull all the levers of favorite conspiracy theories. It's really kind of silly.
Great example of bad journalism.
Oh yeah, if you needed one.
If you want to even call it
I was going to
journalism.
say, is this journalism?
No.
What is it?
It's graffiti with punctuation.
Yeah, this is a family show.
Great title, Graffiti with Punctuation.
Yeah, that line's been used.
It has?
Yeah, that was from Contagion.
Okay.
Yeah, the guy says, you're not a journalist, you're a blogger. It's just graffiti with punctuation.
Is that something they made up in Contagion?
I'm pretty sure that line was from the writers of that movie, yeah.
Speaking of Contagion, I'm serving as a script consultant for a new TV series that's coming out.
Cool.
Oh.
And they said they would put the link to TWiV at the end of each episode, so that's nice. That's my payment.
Excellent.
That's my payment. But the whole premise is that these guys are in a BSL-3 and they're making a dangerous virus, right? So they infect cells and they go, oh my God, all the cells are dead. And I said, no, you can't say that you made a more dangerous virus. He said, well, what do? I said, you need to have at least some animals. He said, well, I don't think we can get animals on the set. It's funny. It was, and then he stopped corresponding. So I have a feeling. Anyway, Kathy, would you take the next email, the next follow-up, please?
This is from Phoebe, right?
Mm-hmm.
Hi, Vincent et al. I'm a microbiologist at a liberal arts college. My students and I love your show. I just read a paper in which the authors showed that ion channel blockers already in use for various cardiovascular problems inhibit filovirus entry at clinically relevant concentrations in cell culture. Although I know a little about clinical trials starting from scratch, I do not know how trials for off-label use of medicines proceed. Do they still begin with extensive testing in animals, for example? Can you talk about that or discuss off-label use of pharmaceuticals to treat viral infections, if that has turned out successfully in the past? The reference for the 2014 publication I'm referring to is pasted under my signature. What do you think? Would you try these drugs as pre-exposure prophylaxis if you were about to volunteer in a hospital during the current outbreak? Will you let me know if you plan to address my question on the podcast, please? Cheers from Colorado Springs. Phoebe. So, first of all, if drugs are going to be used off-label, my understanding is that physicians can just go ahead and prescribe them. If the drug companies want to get them to be on label so that I guess they can advertise their use for a different disease, then they would go back presumably and do more testing in people. But I doubt if they would need to go back and do tests in animals. I don't know.
They don't know. They would just do it in humans.
Right. So where they start with a phase 1, they don't have to do a phase 1.
No,
right?
no. They start with it's basically a phase 3.
Yeah, efficacy, right?
Yeah, it's an efficacy trial because you already know the drug is safe,
right?
And you already know from your clinical trials the first time around that it's efficacious against one thing, and then you've got doctors prescribing it presumably, and you just want to be able to advertise that you can prescribe it for that and sell it for that indication. Then you go back to the clinic and you do this is a somewhat lower risk trial, but it's still, since it's a clinical trial, it's still very expensive, which is why that's usually only done if there's a pretty compelling business case where the company's going to sell enough of the drug to make up the cost of doing the clinical trial on that.
Yeah.
And I don't think that would really happen in this case.
So, Alan, you've talked about this before. The company cannot promote off-label use, but the physicians can, right?
Exactly. A physician can prescribe any drug for any indication. Now, the caveat on that is they can also be sued for prescribing a drug that's inappropriate for an indication. So you don't see physicians just prescribing stuff willy-nilly because there's a check on that in terms of malpractice. But if in their clinical judgment this would help this patient, then they can do it, and it's often done on the basis of studies like this, where there's preclinical data and the doctor is there, and as I think I've mentioned, doctors, MDs and PhDs think a little differently. So as PhDs, we would stand around and say, well, but we don't know that it works, and the doctor would say, look, I got a sick patient, I'm giving him this.
These are compounds.
We've been through that with Tamiflu, right?
Yes.
Yeah. These are compounds that have been approved. They're like ion channel blockers, right?
Yeah.
But the study that Phoebe sent us only looks at their efficacy in cell culture.
Yes.
They say filovirus entry. So you don't even know if it would work in an animal to inhibit.
No.
So I personally, if I were offered this and there were no animal data, I would say it's probably not worth it. I don't know.
Yeah, I mean, it would be. This is the kind of thing that, it might help, and I don't know if you've got Ebola, and obviously at that point things are pretty bad. I don't know, on the other hand, what the side effects of a drug like this might be in the context of an active Ebola infection.
Sure.
Right. The paper does talk about the known side effects and says something that's reminiscent of what we were talking about last week, is that the side effects are generally manageable, especially in the short term. Importantly, they would be clearly acceptable if the drug at the same time increased the odds of survival in the setting of acute filoviral hemorrhagic fever. So, yeah, if that's all you had, and as Vincent said, if there maybe were some animal data, then you might try it even if it hadn't been tested for efficacy in people. But I don't think, to her question, I don't think I wouldn't do it as for pre-exposure prophylaxis.
No, and it is possible, depending on, I mean, from what we know of Ebola pathogenesis, this is a virus that is not, it's not neutral in terms of what it's doing to your circulatory system. And throwing this drug in there, I don't know, it might help, or it might make things worse.
Yep.
That is a possible outcome, and that's why you would need to do some kind of clinical trial on it. But, of course, the clinical trial would be extremely difficult because you've got this virus that's very rare and sporadic and only breaks out in places where there's virtually no healthcare infrastructure.
Yep.
To her question about has there ever been off-label use in viruses that we know about, I wrote to one of our infectious disease docs, and he said, I can try to think of an example of an antiviral, but I haven't. And he said, but there is an antiparasitic which is now being tried and may be effective against influenza. So,
well, I mean, you wouldn't necessarily know about off-label use because no one's going to publish it. And
right.
It might be published as a case report.
Yeah.
And that's where those things initially sort of accumulate.
Yeah, I'm sure they're out there. Yeah. Listeners, dig it up, please.
Yes. Get on that.
Alan, can you take the next email?
Sure. Adam writes, Dear Vincent and guests, I wanted to write in and thank you for devoting an entire TWiV to the current Ebola virus disease, EVD, outbreak in West Africa. The reality is that West Africans are not the only populace with a rather poor knowledge of the Ebola viruses and EVD. Most people in Western nations have largely received what little, if any, knowledge they have from sensationalized news articles filled with references to the infamous 90% CFR and the still not entirely well established, despite the porcine study you mentioned, claim of aerosol transmission in Reston virus, and a certain New York Times best-selling book. I'm just starting my PhD, and as I plan to work with these and other unpleasant viruses, I've been the recipient of a carpet bombing of email, text messages, etc., with questions, most of them on the order of, "Are we all going to die?" So thank you for providing this podcast and other links for me to provide along with my answers. Oh, and I seem to recall that someone mentioned Zbov would be a good name for Zaire Ebola virus. That actually was the abbreviation for some time before it was changed by ICTV a few years ago. Attached is the paper describing the changes in taxonomy. And he sent a link to the taxonomy paper.
Which pretty much says it all in the abstract.
Yeah,
I believe. I didn't
Yes.
try to open the paper. I read the abstract and said, okay, that's it.
This is Jens Kuhn is the first author who we had on TWiV.
Yep.
And we'll come back to talk about taxonomy at some point. So we can dig into that. Rich Condit, can you take Paul's, please?
So Paul has wrote us and inspired, was one of the inspirations for the Ebola podcast before, and he writes, "Thank you. This is a fantastic podcast. Absolutely everything I was looking for. Comprehensive, objective, and accessible. All the information a concerned citizen needs in a glycoprotein envelope. I'm busily infecting my colleagues and friends with accurate news. Thanks again, a grateful listener." So you're welcome. That was a fun episode, actually.
That was,
Great.
yeah.
I learned a lot.
I am glad that Paul listened.
Yes.
Yep.
We had
Good.
another email last time that was stimulatory also, but I don't know if he has listened. Anyway, I'm glad you like it. But, the best thing you can do is to spread this pseudotyped information, right?
Yes.
One of the title possibilities, all the news that fits in a glycoprotein envelope. That's cool. I like that because that pulls on Paul's thing. I was wondering where that came from.
That's where that came from.
Next one's from Marty. Thanks for taking the Ebola crisis once again in TWiV. I'm a retired computer science professional and became interested in virology as the H1N1 pandemic began. I decided to track the case data coming from WHO and CDC. I thought it would be instructive to watch the data in real time. This is the lead to finding your course out on iTunes U, and I watched every video. I love math, so did some research and found some journal articles on several variations of the SIR model and used MathCAD to do some modeling based upon the data. I'm now watching the data on the current outbreak in West Africa, and I'm concerned about what I am seeing. So he sends us a plot of the cases, number of cases with time. He says, it looks like prior to day 50, control measures were working, and the rate of change in cases was decreasing and approaching zero. Do you have any thoughts on what happened between day 50 and day 60 to generate what now appears to be continuing exponential increase in the number of cases? I ran a log linear regression from day 59 onward and calculated that the number of cases is doubling every 29 days. Given that this is partly driven by sociological factors, limited medical facilities, and the current rate of growth in the number of cases, is it possible to regain control of this? Well, I would say that he says prior to day 50, control measures were working. I'm not sure you can conclude that at all.
No.
I think it was early in the epidemic and the number of infected people. The more infected people you get, the more they infect. So that could account for an exponential increase. So it may be that they had to reach a certain number. I don't know the reason for this uptick in cases. Maybe you guys have some thoughts.
Well, it
Well,
only
we're
looks
also-
like an uptick because if you think that it was leveling off before, okay? If you just, if I just draw my visual line through this, it's one interpretation of this, though, I don't know how statistically relevant variations in this curve are, but one interpretation of this is that it's been the same rate from the beginning.
Right.
I have heard discussion about, I think from, I don't know if it's people in NGOs or something, alluding to the fact that it did seem like it was kind of getting under control and then it suddenly exploded again. So that would fit with his interpretation of the way the data look. And I suspect that there will be lots of papers generated from trying to figure this out. So stay tuned.
I mean, it's simple. One explanation is that a lot of people were getting sick and staying home, and then suddenly they were brought into hospital, and that increased the transmission. But you're right. I think we'll learn about this in the coming years.
By the way, the SIR model that he refers to is one of several models to describe how infection spreads in a population. And S is susceptibility, the number of individuals not infected with the disease at a given time. I is the number of individuals infected with the disease capable of spreading it. And R is the number of individuals who've been infected and then removed from the disease, either because of immunization or death. And there's a bunch of equations to use all those variables to try and model disease spread. And there are other models as well.
So yes, is it possible to regain control of this? Well, and we talked about it last time. I think you could stop people from leaving the country. You could improve the healthcare system. You could get people to stop burying their dead. You could give them intravenous fluids and antivirals and monoclonal antibodies. Yeah. Whether we can or not is the question, right?
Yeah. Is it possible to vaccinate everybody in Nigeria against polio? Well,
no.
That's
that's right.
That's the level of the problem here, is that we can't get the basics into these countries because there's not enough of a functioning government.
Yeah.
One thing
go
ahead. I was just going to add, it's a little bit of a digression, but just thinking about the fact that I think there will be people writing and analyzing all of the epidemiology of this, for some time to come. Last week when we were talking about when the first cases were, I had heard something about the earliest cases perhaps being in December. And then shortly after that, there was a big article in the New York Times about patient 0 probably happening last December, being potentially a 2-year-old child. Mm-hmm. So epidemiologists, are working backwards on that kind of thing, and they'll continue to try and analyze all this data.
Yeah, we talked about that Lancet paper, which was the first, not Lancet, New England Journal, I think, right? With Jens. That was his, how far back is that? Let's see. New England Journal, here we go. Emergence of Ebola virus disease in Guinea preliminary report. So they say March, yeah. But yes, I think they also mentioned in that paper that it could have been way back in December, as you say. Yeah, here we go. 9 deaths from December 2013 to February 2014. Yes, so they went back, and it did indeed start in December. Yep, from a single crossover.
It is interesting that his graph is a clear exponential increase.
Mm-hmm.
Yep.
Yeah.
All right, Kathy, can you take Layla's email?
Sure. Layla writes, thanks for sharing your timely thoughts on this issue. I'm curious, though, why the dismissal of Richard Preston's The Hot Zone? Does every science writer have to be a scientist? Isn't it enough to have qualified sources and fact-checking? Yes, the book was luridly written and portrayed certain personalities in a less than flattering light, but I couldn't find much mendacity in what he presented. If you could share any mistakes that stood out for you, it'd be appreciated, as this book still pulls a lot of social weight, not only because it was a bestseller 20 years ago, it's required reading for countless secondary school curricula.
That's depressing.
Yeah.
Yeah, I've read it so long ago. So I emailed Tara Smith, who is a epidemiologist, and Alan picked one of her Ebola pieces last week. She said it was more the use of the most dramatic examples, perhaps factual but skewed, that by their totality gave a misleading overall picture, basically cherry-picking to maximize drama. So it's so long ago for me. All I can remember is that I didn't like it.
It was a long time ago for me, too, but I remember that what I didn't like about it was how poorly written it was. I had to force myself to finish it. It was just such bad, I couldn't call it even literature.
I found it incredibly annoying.
Yeah.
Yeah.
I just remember that, he overstates a lot of this stuff. I mean, first of all, you're not going to learn virology by reading it because there's not a lot of virology in there. And what's funny, last week I think it was, I don't know if I mentioned this on air, but he was doing a Ask Me Anything on Reddit, and my son was there. He said, Dad, this guy says he's an Ebola expert. So, I mean, I think I'm not an expert on Ebola. Do you consider yourself, Kathy and Rich and Alan?
No.
I think you have to work on it to really be an expert and think about it every day. You could certainly learn a lot about it, but to present himself as an expert is really not fair. And I think that's how the book is written from this perspective. I have to go back, and now I have to read it, and I'm going to underline everything that's wrong for you.
He warps everything. I think it's true. There's not any. It was a long time ago that I read it, and I strongly remember my impression of it. But there wasn't anything that I can think of that was just flat out wrong. So it would pass a fact check, but it was just totally cherry picked, exactly like Tara says. It's just every example and every data point that he could pick, he picked the most flagrant one and then generalized from that. And it just really is a very deceptive way to cover a scientific topic.
I actually haven't read it, and now I'm not going to waste my time. My exposure to it is that it was quoted several times in Spillover, in the context of it being an exaggerated description of the disease. One other thing, referring to this email, the question was, does every science writer have to be a scientist? And I think the answer to that is no.
No, of course not.
There are very good science writers who, yes, use qualified sources and fact-checking in an intelligent fashion. First thing that comes to mind is actually Seth Mnookin and the Panic Virus.
Yes.
Okay, I thought that was a great book and really well-researched. So, no, you don't have to be a scientist, but you have to, do it right.
I think it really helps to send your manuscript to a scientist who's working in the field, all right? And I don't know if Preston did. It was 20 years ago. But Rebecca Skloot sent me her manuscript on HeLa cells, right? And I picked up a bunch of stuff that got corrected. And she told me once that not every author can afford a fact checker. You have to pay them.
Yep.
Right? So a lot of people don't. So there you go. So on Twitter, Colm, follow up to last episode, he sends a paper on high throughput antiviral screening in a BSL-4 facility.
This is a
we had a question that came up last time as to whether or not you would do high throughput drug screening on a BSL-4 agent, because we looked at some papers where they used pseudotyped viruses so that they could look for BSL-4 pathogen type antivirals in a safe environment. And we questioned whether you would do this kind of thing in a BSL-4 facility, and Colm straightens us right out here. Yes, indeed.
Yeah.
It's a good example.
These folks did.
Yeah, it gives you more targets, for finding inhibitors, because the pseudotypes basically target entry.
Automated testing of 10,000 compounds a day was the capacity of their system, which is pretty decent.
It's nice.
Yeah.
The next one is from John, who sent an article, said, Ron Paul is advocating DDT use for Ebola.
And gives a link to a little video that Ron Paul has. It's I guess a weekly or regular thing.
Yeah, so, of course, Ebola is not transmitted by anything that would be killed by DDT, right? So...
Yeah,
it's a little confusing. I don't think he was actually suggesting DDT be used as for Ebola, because he kind of drifted off into malaria.
Yes.
Okay, and I think that's where he was suggesting reintroducing DDT, though he's not really clear in the podcast, and I could see how one would get it confused.
Yeah, he uses Ebola as a springboard and then talks about the much, much larger burden of malaria, and that's correct. And then he drifts into we should use DDT because it's cheap and doesn't hurt anybody, and the fears are overinflated. And this is actually a very, very common trope of right-wing groups that Silent Spring was a lie and everything's peachy with DDT. And I think the main reason for making this argument is to just tick off people on the left who are environmentalists. It doesn't really have any scientific merit, and I actually answered a very similar argument on my blog back in 2006 when it was trotted out last time before an election. So that's kind of what's going on here.
Rich, can you take the next one?
Right. John writes, Dear Plague Panic Preventing Podcasting Professors.
Can that be our title?
That could be a title.
That's good.
This is going to be another Ebola episode, isn't it?
Your Ebola discussion mentioned that ZMapp only provides temporary protection, but did not say how long. According to the internet, the lifetime of antibodies in the blood can be days to a few weeks, depending on type. How long do the ZMapp antibodies last? This doesn't matter if antibodies are given as post-exposure treatment. If a large quantity were available, it could be given preventatively, say to healthcare workers, and then the duration of protection would be important. And he adds, P.S., it's 22 degrees and sunny in eastern Mass, and more importantly, the dew point has dropped to a tolerable 10 C. P.P.S., can a triple monoclonal antibody be called a triclonal antibody? Well, first of all, I looked around on the internet for an answer to his question, and the best I came up with was a CDC site about immunity that covers passive immunity, among other things, and there it was the strongest commitment I could get to this question from anywhere I looked, and it said a few weeks or months. And the other thing you come up with frequently is a talk about maternal passive immunity. Okay, many people may be familiar with the fact that maternal antibodies are passed on to infants at birth and through breast milk that can be protective of infants against diseases for some period of time. And that's the same thing, a few weeks or months. I think we know, it's possible we know more about that maternal immunity in terms of passive immunization because we have more experience with it than others. The other thing that came to mind when we were talking about Ebola is that when you treat somebody with an antiviral or a passive immunization under circumstances where they're already infected, so you get transient relief from the treatment, but at the same time, if they're infected, they have an opportunity to mount their own immunity at the same time. So quite often when the therapy is gone, they're immune because they have been infected. So you get natural immunity that extends beyond the initial treatment.
Right. The treatment sort of buys their immune system some time to actually do its own thing.
Right. And I would call the triple monoclonal antibody trivalent.
Right. The monoclonal refers to the single epitope specificity of each antibody, so it wouldn't be triclonal. It would be a mixture of monoclonals. I asked my pharmaceutical wife, and she said you can do things to the antibodies to prolong the duration in the blood, like you could pegylate them, and it would last longer, and people are experimenting with that. But she said also it's very difficult to measure, right, the specific antibodies that you've put in, and so it's not often done. But I would say, at the most a couple of months. If you're doing preventive prophylactic use of these, you'd have to do it regularly because you're probably not going to know how long it lasts unless you actually do the experiment in humans, which at this point...
I even find the notion of a couple of months kind of surprising. I mean, you're injecting a protein into somebody. Yeah. I would expect that would last for a whole long period of time.
Yep, but I agree. Alan, can you take James?
James writes, Kia ora, folks. In TWiV 297, Vincent makes an offhand comment wondering why people in Beijing would be researching Ebola. China has quite a strong economic and diplomatic commitment in Africa, so it has many expats located in the areas endemic to things like Ebola. So just like the U.S. put research effort into diseases that were in areas where Americans were, but the diseases never were in the U.S., so does China. Keep up the neat work.
Thank you, James.
Yep. Good point.
When people start saying he made an offhand comment, I get worried.
Yes. What did I say now?
Don't make any offhand comments, okay, Vincent?
Well,
you're going to get mail.
Stick to the script that we worked out beforehand.
Yeah, right.
That's part of the podcast, right? Offhand.
I think the whole podcast is offhand.
Last follow-up, Kathy.
Lewis writes, and this is regarding yellow fever vaccine and old folks. He sends a link to an MMWR article, and I went and looked. I think his link was to one from, actually I don't remember what year, but then I found something for 2000 or 2002, and then I found a more recent one for 2010, which basically confirms or gives some data for what I was told about the vaccine. During 2000 to 2006, there was a rate of 4.7 serious adverse effects per 100,000 doses distributed. Reporting rates were highest among persons aged over 60 years, where the rate was 8.3 per 100,000 instead of 4.7.
Mm-hmm.
And so then they say that age over 60 years is a precaution for the primary inoculation with the vaccine. You could potentially get a boost, I suppose, after 60, but then they also say that there's probably really long-lived immunity. So depending on when if your first dose was when you were 20 and you're now going to go to Brazil at age 65, maybe you do want to get it boosted. I don't know. But you might have to argue with the insurance companies or your doctor or something to get that to work, to get that to happen.
The three serious adverse effects that they list are immediate hypersensitivity and anaphylactic reactions, vaccine-associated neurologic disease, and vaccine-associated viscerotropic disease. It's that last one that I was clumsily trying to remember as we were discussing this last time. And the first article that he links is, to me, remarkable for they describe 6 case studies with either of these two nasty ones, the neurologic disease and the viscerotropic disease. And these people get really sick. But the remarkable thing is that then they recover and walk home. Mm-hmm. I mean, it's incredible how sick they are, and then they come around. So nobody died from this. Well, there may actually be deaths from some of these. I don't know. But even though these are serious adverse effects, the ones that I've seen described are people who they got very sick, but they recovered.
Yeah, the 25-year-old who spent 24 days in the hospital with renal failure and yada, yada, yada. It's pretty scary stuff.
Yeah.
But so, Kathy, how long after the first inoculation should you have a booster?
I don't think there is a recommendation for that because I think it sounds like the first inoculation is good enough.
Yeah.
But one of the other articles that I went to talks about 4 U.S. citizens ages 63, 67, 76, and 79 between 1996 and 98 became ill 2 to 5 days after getting the yellow fever vaccine, required intensive care after a variety of horrible-sounding things. 3 of the 4 died.
Oh, okay.
So that wasn't included in this second batch of data for the 2010 recommendation, but I'm sure it's in everybody's mind.
We need to emphasize here that, this is bad stuff, but you're still, if you're going to go to a yellow fever endemic country, in terms of odds, you're better off getting vaccinated.
Yes.
Right.
Yep.
But I think this also came up in the context of, should we maybe use a yellow fever virus backbone?
Yeah.
For another vaccine, and I think the answer is maybe there's better ones.
That's right. That's absolutely right. I'm always amazed at who listens to TWiV. Louis is the Chief Medical Officer at America's Blood Centers. That's so cool.
Yeah.
So that last TWiV, 297, had 59 tweets, 320 likes on Facebook, and 12 likes on Google+, which is pretty good. But come on, we need more. We should have tens of thousands of all these things. Spread it to your friends. It's got to go viral, really viral. Right. All right, we do have a paper today, which is about viral oncotherapy.
Which we're going to finally get to now.
We're going to get to. It's a cool paper, amazing paper.
Yes.
It's about viral oncotherapy. And if you look up viral oncotherapy on Wikipedia, you find an article, and at the bottom it says, a number of oncolytic viruses were discussed on Columbia University professor Vincent Racaniello's This Week in Virology podcast, including episodes on myxoma virus, reovirus, picornavirus, and pox virus. So thank you.
I didn't know you were editing Wikipedia now.
No, I didn't put that there. I wouldn't do that. I honestly would not.
I know.
So thank you to whoever put it in. It's not just mine, of course. We have many. We have 4 co-hosts. 1, 2, 3, 4. Yes, and the 4th is in South America at the moment. This was brought to my attention by the man who made the virus that's used in this paper. He's not on the paper, but I met him at a meeting a couple weeks ago. Roberto Cattaneo. I just love saying his name. And one of the authors is Angela Dispenzieri, which is also equally good. And this is called Remission of Disseminated Cancer After Systemic Oncolytic Virotherapy. It's published in the Mayo Clinic Proceedings.
Which are open access, apparently.
Great.
Yeah, I clicked on the link and opened up the PDF right away.
I'm a big fan of Mayo Clinic.
You are?
Yeah. They're one of my go-to websites for doctor stuff. And, well, I am prejudiced, too, because my father-in-law spent many years there as a doctor. But I think they're a great organization.
Did I say the title? I don't think so. Remission of Disseminated Cancer After Systemic Oncolytic Virotherapy. So whoever is doing the Wikipedia thing, now you can add measles virus because that's the therapy in this paper is based on that. Measles virus, the virus they use here is actually derived from the vaccine strain. It's a infectious attenuated strain called the Edmundston strain, and that's of course given to people as part of the measles, mumps, rubella vaccine. And this is very interesting. This virus, this vaccine, binds to a different receptor than the wild-type virus. It binds to CD46. And this is a complement regulatory protein that happens to be highly produced on human myeloma cells. So they're very susceptible to infection with this virus. And the virus is...
Now they modified the Edmundston strain in this case, so it's carrying an additional gene, right?
Yeah, it's carrying a gene called the human sodium iodide symporter, or NIS. This transporter transports iodide ions into cells. And if you put this in the virus, then what happens is the cells that are infected with the virus, they produce the transporter. They can then take up iodide or similar isotopes. So they use this during virotherapy. If you give the patients this virus and then you give them gamma-emitting isotopes, like I-123, you can visualize the virus using PET scanning. It's really cool. So you can see where the virus is replicating.
It's not using PET scanning, is it? If you just give the isotope?
Single photon emission computed tomography. Isn't that PET scanning?
No, that's
positron emission tomography is PET.
All right. Well, it's tomography of some sort where you're seeing the emission from
you're
the
labeling, right? Because the virus is carrying this additional gene, which then causes the cancer tissue to take up, to become kind of a sponge for iodide, and then you give radioactive iodine, and that localizes preferentially to the tumor tissue or to the cancerous tissue, and then you can see it. I think it's just a CT scan. It's just because it's
single photon.
Yeah, because it's radioactive.
And you can also give patients beta-emitting isotopes, okay? And you can give them, and that'll help to further kill the cell. They'll be taken up into the cell that's producing this NIS, and it's like radiotherapy, right?
Right.
Which you
and
do
very targeted radiotherapy because these cells are unusually good at sucking up iodide after they've been infected.
It's a very cool idea. And so Roberto Cattaneo made this virus, MV-NIS, and it's been studied quite a bit before in preclinical studies. In disease models where you take a mouse and you transplant a tumor in, it's shown good tumor destruction. And it's been shown that you can use this NIS to visualize the virus replication, and that you can add the beta emitters and it will help further accelerate destruction of the cells. And phase 1s for this virus in a number of cancers have been started. I think ovarian, the myeloma, which is this one, mesothelioma, and head and neck cancers. So previously it's been shown, as I said, in mouse models, you can give this virus intravenously, and it destroys the myeloma xenografts. If you immunize the mice first with measles serum, so the passive immunization, sort of like ZMapp, right? But for measles, you don't get any anti-tumor activity. So if you have antibodies to measles, this is not going to work very well.
Which is a potential problem.
Yeah, because we are immunizing the population, right? There weren't any toxicities in mice and in non-human primates at the maximum feasible intravenous dose, which means as much as they can make, as much as they can concentrate by their production. So they started a phase 1 clinical trial based on this preclinical data in myeloma patients. And this is kind of a preliminary report on 2 of these patients. There are more, but they're going to be described later. These patients have very advanced multiple myeloma. This happens to be a malignancy of plasma cells, which are the cells that make antibodies in our bodies. And these make diffuse tumors in many different places. And they can be treated, but you never get cured. You can live maybe 3 to 7 years at the most.
There's a 45% survival rate out to 5 years.
Yeah,
and they don't talk about cure.
No. And those are years spent on repeated rounds of chemo.
Right. And these patients were picked because they had received for publishing. They had received a lot of measles NIS in the study in the phase 1. They were measles seronegative, and they were not responding to chemotherapy. So basically, they weren't going to live unless you try something experimental.
And these 2 patients are from their highest dose group, where they gave them 10 to the 11th TCID50, which again is the maximum that they can pump into them, apparently.
Yep.
Actually, I was curious about that number, 10 to the 11th TCID50, because that is a huge dose.
Huge.
Yes.
So I looked up to see what the normal dose of measles is in the MMR vaccine. Ha-ha! 10 to the 3.
Wow, that's a lot less.
Okay, so we're talking about 10 to the 8th times more.
And this study's lowest dose group got 10 to the 6th.
Right. Okay, so because I was interested, there are, as we'll get to, there are not only that, but it's administered IV rather than injected intramuscularly.
Right,
okay,
right.
So we're talking about a very unconventional administration of this virus.
Yeah, it's infused over, what is it, an hour or 2 hours?
Yeah, an
hour. So they've got it. They hang an IV drip with this thing at this high concentration, and they just pump virus into the people for an hour.
And I want to say something else about the disease, because I guess you get, circulating B cells that are doing this, that are proliferating, but it also causes what are called, you kind of mentioned this, plasmacytomas, which are soft tissue focal lesions. Okay, but this is important because there are foci that you can see and sometimes palpate. One of these patients has a palpable lesion, and that allows you some sort of physical assessment of whether or not the treatment is doing anything. And also, these B cells spew out sometimes large amounts of one or the other of the immunoglobulin chains.
Right.
And so they can be assessed as to what your tumor load is by whether or not you have these immunoglobulin chains circulating in your blood.
I think they are clonal, right?
Mm-hmm. Yes.
So they get clonal, which is not what your antibody response is, right? It's very diverse, but in this case it's different.
Right.
There was sorry, go ahead.
I was just going to say, and I think about these plasmacytomas as just sort of, this disease is almost naturally metastatic. In other words, that these tumors can be all over the place just by the nature of them being a blood cell cancer.
Right.
So in the bone marrow and everywhere else, that's right, yeah. So there's a technique they use here, and this is why I said PET scanning before, because you can these tumors, if you give patients radioactive glucose, basically it's glucose with a fluorine on it, fluorodeoxyglucose. This gets taken up into the tumors, and then you can image that by PET scanning, and it's one way of measuring the tumor mass, and that's what one of the things they do in this paper. So that's why I was thinking of PET.
Mm-hmm.
All right, so 2 patients, which we've described, and they gave them, let's see.
Did we say that they were seronegative for measles?
Yes, we said they're seronegative. They're at risk for imminent death, as I said before.
Those are pretty much the criteria for entry into the study, I gather.
And patient 1, 49-year-old woman with had gotten lots of therapy and was no longer responding to, and doing PET with this fluoroglucose showed progression of her tumors and so forth. She had lots of masses. Patient 2, 65-year-old woman, again, lots of treatment, lists and lists of treatments that she
incredible
received.
List of treatments she'd received, yeah.
Palpable tumors. One of them, I think it was this one, had just before the treatment was growing a mass on her chest, I think.
I think it was the 49-year-old had a mass on her head.
Right, yes.
And the 65-year-old had, innumerable palpable soft tissue plasmacytomas.
Right.
So they gave him 10 to the 11th TCID 50s intravenously over an hour. It's just in 100 mLs of saline.
Yeah.
Now, this patient 1 developed a severe headache within this 60 minutes, and they gave her aspirin or acetaminophen. 2 hours later, it became febrile, tachycardic, hypotensive, with nausea and vomiting, and they treated that. And after the next few days, they had fever. But they got all the virus into this patient.
There's a video that accompanies this where one of the physicians involved describes this, and if I remember correctly, describes that it was a pretty tense situation because she had a pretty serious reaction, and they actually interrupted the treatment for a little while, and then continued it. So it was pretty tense for a little while.
Yeah, they even say in the paper the infusion time of 60 minutes included a brief interruption for her, and they go through this, and she had some side effects.
Right.
Yeah, the second patient also got the same infusion. 2 hours after infusion, became febrile, tachycardic, hypotensive, same symptoms as the first.
Yeah.
And they treated her with intravenous hydration.
And they recovered.
It's interesting. It must be, I don't know the cause of this, but I would guess that it's partly
the 11th virus.
Yeah, partly interferon response,
Yeah,
something like that.
Mm-hmm. I mean, you're putting so much virus in the dendritic cells and other cells are probably churning out interferon, which have all these effects, at a high level.
Yeah, I would have been shocked if they had not had some kind of reaction to this.
So what happens to these people? 36 hours, patient 1 noticed the plasmacytoma on her left forehead had softened. She felt it was getting smaller. And by 6 weeks, it was no longer palpable. So this is something that Roberto told me. This is just remarkable. 36 hours. I mean, he said that the virus cycle is shorter than that. But to get substantial replication, it does take a few days. So this is amazing that it's already having an effect. So you can measure the antibody proteins in the blood and the ones produced by the myeloma, and they did that, and they could see that it went down considerably in both patients. Their
measles antibodies went up considerably.
Measles antibodies went up. Got a good measles immunity now.
Oh yeah.
The bone marrow plasmacytosis resolved. So this unusual histological presentation of the tumor in the bone marrow, that went away. One of the patients 9 months later, I think, began to have a recurrence of the tumors because this deoxyglucose measurement was done, and they could see that there was increasing uptake in the right frontal lesion.
So patient 2, I think, had less of a response than patient 1.
But they say most of her lesions were gone except this one on her forehead, and I think they treated that locally.
So that was patient 1. Patient 1 went into basically to remission, and then that thing on her forehead, she had the one on her forehead, that kind of came back, and they started to treat that locally,
yeah.
but otherwise she seems okay. Patient 2 had a good response to start with, but then everything seems to start coming back, including a circulating antibody
Yeah,
change.
that's right. So then they gave them radioactive iodide, and they could image the replication of the virus in the tumors. And you can see they have some images of this over time, and you can see one of the lesions disappearing. I think one of them, there are a couple of panels here. I think one of them is whole body. You can see lesions disappearing. That is, there's no longer virus replicating in them, which could be in part because the cells have been destroyed.
I like this table too. That the table also I like that shows what not only the increase in the antibody titer, but they measure measles RNA copy number. They don't actually they don't tell me the real units, copy number per what. But at least I can see what happens here. And, there's, of course, initially a big spike that peaks at about 60 minutes. And then it fairly rapidly, most of it clears, but they can still detect stuff out through day 15 and in one patient out through day 42. But then by 3 and 5 months, it's basically gone. Okay?
Yep. Mm-hmm. So they have glucose, imaging of the tumors, and you can see the one on the skull going away, pre and post treatment. So it's really basically what's happening. The virus is getting into all these tumors and replicating and killing the cells.
Yeah.
So
only in the tumor cells, no other tissues, no spread from the plasmacytomas to normal tissues. They say they can't see it by their imaging.
Yeah, and
Right.
it seems like other than the initial quite understandable febrile response that they had, they don't seem to have any other problems that are from this.
And one of the key issues in this paper is being able to administer this stuff systemically, that is circulating,
Right.
and nevertheless, rather than injecting it straight into a tumor, which of course for a circulating tumor you have to do that anyway, and have it actually target the tumor. And there's some ideas about why it is that measles can actually target the tumors, right?
Yeah, I think part of it is the myelomas have high CD46 expression, right?
Right.
But you would think it could infect other tissues as well.
Right. That's what I was going to say. The whole thing about these is that specificity only for the tumor cells is really important.
I mean, CD46 is produced elsewhere, but
Right.
apparently it didn't lead to substantial replication. So they do say in the discussion, the complete remission of a disseminated malignancy mediated by a systemically administered virus has not been previously documented in a human subject. So we did a paper on a vaccinia virus, JX594. You may remember that.
Right.
Generex.
But I think that was intratumoral.
It was intratumor, right?
Yep.
And they talk about
Right.
that, yeah.
Right. And also the sort of commentary on it talks about a TWiV virus being developed by Amgen that does have systemic activity, but it also requires multiple local injections.
Right. And of course, the next step that they're talking about with this is to take that step to radiovirotherapy, where you would add on to this. You'd give the virus once it's getting into the cells. You've got the iodide uptake, and then go in with your I-131 and nuke 'em.
Yeah, so this is quite interesting. Of course, if you have antibodies, as we said earlier, then this won't work.
Well,
Right.
there are studies that show that if you administer antibodies passively before the I think these are animal studies,
Yeah,
really,
that's right.
before the vaccine, that it neutralizes the vaccine. However, 10 to the 11th TCID50, I don't know that.
It may not be a problem, yeah.
you
That
may
may
be
not
able
be
to
a problem.
titrate the antibodies, and also doesn't measles antibody titer decline over time, even if you're vaccinated?
Yeah, sure.
Well,
think so.
so I asked the infectious disease doc that, and because that was one of my concerns. And they talk about it, again, either in the commentary or the article itself, and say that at least in these patients, it's maybe not such an issue because neutralizing antibodies against measles would be at very low levels because the disease itself and the current therapies used to treat it are immunosuppressive. So in other words, they've gotten all this other chemotherapy, so they're going to have pretty low levels. But measles titers persist for life generally. It would have to be evaluated. But this therapy might still work depending on the route of administration.
If you look at the time course of measles genome copy numbers, there's basically nothing by day 3, right? And even if you have a memory response, it's going to take 14 days. Well, maybe it won't take that long. It would take a week, I would guess, or less. So maybe there's a race. You put so much virus in, as Rich has said, that you can do the infection before even the memory response kicks in. Maybe that's part of it. But obviously we'll have to study this in future trials,
Well, and these are only 2 of, 6 patients in this trial who are getting different doses, and implied in their description is that I got the sense, at least, that some of the other patients are not seronegative for measles. I would think finding somebody who's seronegative, who's 50 years old and seronegative for measles would not be easy. Okay,
right.
So my guess is that there will be at least some small numbers of data on people who have pre-existing measles immunity coming out of this as well. In terms of targeting tumor cells, now we don't really know what's going on here. We've mentioned the idea that the vaccine strain is using a receptor that is overexpressed on the myeloma cells, and that may be a component of this. But one of the things that gets discussed all the time that I find fascinating is that there's a lot of overlap between growth control and antiviral pathways. Okay, and so tumor cells that are broken in growth control pathways are quite often also broken in antiviral pathways. And that makes them, at least in theory, more susceptible to virus infections.
Sure. Yeah, right.
So I think that's a really interesting concept. And also, there's another overlapping part of this as well, and that is that viruses try to counteract antiviral pathways, and in doing so, sometimes compromise growth control pathways, and that's one of the mechanisms by which viruses themselves, this is the flip side, might be oncogenic. And that goes back to an episode we did quite a while ago with Pat Moore, where I was introduced to that concept. It's very interesting.
Right.
Yeah, there's a wonderful review article, unfortunately, probably behind a paywall, in Nature Reviews Microbiology. It's by Meest and Catania, New Viruses for Cancer Therapy, Meeting Clinical Needs. And in a table in this paper, they mention the specificity in part being the deficiency of tumors in the innate response for this particular virus. So we have, in terms of viruses, it's a very interesting table. They have 9 families, representatives of 9 families: herpes, adenovirus, pox, parvoviruses, paramyxo, picornaviruses, rhabdoviruses, retroviruses, and reoviruses. These are all in clinical trials. And they
Are you looking at Table 1?
Table 1.
Yeah, because he didn't actually name the virus families. I had to figure it out from the cartoons.
The virus families are in the table. The viruses may be...
Okay,
actually,
maybe just the way I have the table displayed. Okay.
Yeah, but anyway, there are links to the clinical trial registry for each one, which is really useful. Clinicaltrials.gov. You can see what's going on for each of them. So, for example, if we click on the measles one, we see that we have a recruiting trial. This must be the next step, maybe? No, this is phase 1. It says they're currently recruiting participants at the Mayo Clinic. But it's a pretty cool resource there. I'm amazed at oncolytic virotherapy, how it's progressing. I'm just amazed. I guess I shouldn't be anymore, but it looks like at some point in the future, this is really going to come of age and be used widespread because these are all clinical trials.
Really seems to be coming together.
Amazing. Anything else?
I wanted to mention that you had Roberto on TWiV when you were at the University of Minnesota.
That's right, yeah.
So that was TWiV 232, Gophers Go Viral.
Yes, he talked about discovering the receptor that measles, wild-type measles virus interacts with. Of course,
on the epithelial cells
of the lung,
in the exit. Yeah.
Nectin-4. Okay, let's do some email. The first one's from Jacob, who writes, "Greetings from sunny Australia, 12C and 30 kilometer per hour winds." Yeah, I was just there. It's winter. Saw this email today about the 2015 Viruses Awards and thought it should get some airtime on TWiV. Yeah, so this is a contest being run by the Journal of Viruses, Junior Investigators in Virology and Travel Awards. So if you're a junior investigator, postdocs, also PhD students, you can get some support here. So you should check that out. It's it's money to travel
to a virology conference. So sounds like kind of any virology meeting.
Yeah, it's very nice. All right, Kathy, I'm going to let you take the next one so you can pronounce his name.
Sure. Myelo writes, "Dear Vincent and other TWiV gang members, during the many years I've worked on the genetic characterization and evolution of human and animal rotavirus as a PhD student and as a postdoc, I always had the feeling that I wanted to know more about other viruses, but I just never got around to doing it, as I didn't know where to start. TWiV has been the perfect solution to this problem, and ever since I discovered TWiV, I've been an avid listener during my daily 40-minute commute to the lab and back home. I was very pleasantly surprised to hear Sarah McDonald on your latest show, TWiV 285, and even more so that she mentioned some of our work. It was also nice to hear that you know Ulrich Desselberger. He is a very good friend of mine, was a jury member during my PhD defense in 2008 in Leuven, Belgium, and he is one of the grandfathers of rotavirus research, and as Sarah mentioned, still actively doing research at the bench. Because one of the recurring themes on TWiV is viruses isolated from bats, I would like to add a small chapter to this storyline. As Sarah mentioned, human rotaviruses have a limited number of conserved genotype constellations, which seem to be most fit, despite the fact that the VP7 and VP4 outer capsid proteins appear to be more readily exchanged during reassortment events. Although the number of completely sequenced animal rotavirus genomes is more limited in comparison to human rotavirus strains, it also appears that different animal species, such as pigs, cattle, and horses, also possess a set of rotaviruses with more or less conserved genotype constellations. The first partially sequenced bat rotavirus genome was published by Matthew Azona and colleagues, and this rotavirus was isolated from a straw-colored fruit bat in Kenya, and he gives the reference. I was involved in a paper describing the second bat rotavirus, which was sequenced completely after its detection in a viral metagenomic study in lesser horseshoe bats in China. Gives the reference for that. The genome constellation of the second Chinese bat rotavirus strain was entirely different from the first bat rotavirus strains from Kenya. Recently, this same Chinese group found another bat rotavirus in the Stolichka's trident bat in a location more than 400 kilometers away from the place where the first Chinese bat rotavirus strain was identified. Complete genome analysis of this strain revealed that the genotype constellation of the two Chinese bat rotavirus strains was nearly identical, except for the VP4 outer capsid protein. This suggests that the genotype constellation might be typical for Chinese bat rotaviruses, although further research is warranted. Further phylogenetic analyses surprisingly revealed that an unusual completely sequenced equine rotavirus strain from Argentina and two partially sequenced human rotavirus strains from Thailand shared a nearly identical genotype constellation with the two Chinese bat rotavirus strains, suggesting that these unusual human and equine rotaviruses may be examples of direct interspecies transmissions from bat rotaviruses to humans and horses, respectively. We have submitted these findings as a dispatch to Emerging Infectious Diseases. If these findings would be further confirmed, rotavirus can be added to the growing list of bat viruses that can be transmitted and cause disease in other host species, such as humans and horses. I hope you like this new chapter to the TWiV bat virus storyline, and I would be happy to hear your thoughts on it. Keep up the awesome work. Yella. And gives the way to pronounce Yella, and says that the current weather in Leuven is 19 Celsius, 67 Fahrenheit, cloudy with a humidity of 77%. Actually, I don't know whether Yella is a he or a she. So
I'm seeing if it's been published yet, but I don't. Here we go. Oh dear, is it straw-colored fruit bat?
Mm-hmm.
Yeah, it's been published.
Mentioned.
It's not right. No.
Well, no, that's the PubMed 21122212.
Yeah,
that's
the
sorry.
old one.
Yeah,
That's already
right. So the new one is
not out yet. Yeah.
Okay. Meanwhile, Yella is a male given name.
Okay.
It's really.
However, sometimes also used as a female name, Yeltsin.
Okay.
According to Wikipedia.
It's not surprising that you would get this sort of thing from bats to people, right?
Right.
Many other virus families can do that, and they have lots of viruses in them. It's just a matter of figuring it out, I think. But when your paper comes out, we'll take a look at it. It's pretty cool.
Are bats really, really unusual in this regard? Or is this just a matter of the attention that we give them? Or that they fly around?
I'm sorry, what was your question? I'm distracted by this chatting between Alan and Kathy.
I think we've talked about this before. There's something about bats. There's
something about
the
bats.
pathogens, pearls, where they talk about what it is.
Go listen to the Lin Fa Wang. Yeah, he talks about this. High metabolism. We talked about it quite a bit. Yeah.
Yeah.
So it's not surprising that there's a rotavirus and there will be other viruses shown to be transmitted as well. It's cool to document it. It's important, sure. For sure. Yep. All right, Alan, you're next.
Joe writes, TWiVers, 2 follow-ups. First, fair and balance alert. You all were whacking the anti-vaxxers on the right appropriately hard, but here in California I run into many more anti-vaccine advocates who are on the extreme left and very vocal about it. Mostly seems to come down to the fact that vaccines are not natural and contain chemicals and impurities. Jenny McCarthy is the obvious example. In fact, we have a local left-leaning alternative high school that has had a series of outbreaks over the years due to the concentration of unvaccinated kids. I can remember them being in the news for mumps and meningitis and I think measles. Stupidity finds a home in all portions of the political spectrum. My favorite delusional science explanation from my public outreach days was the person who with great earnestness told me that, of course the Gaia hypothesis is science. That's why it's called a hypothesis. Hard to argue with that. I think we've hit the left end of the spectrum on the anti-vax folks. That's a well-documented phenomenon.
Yeah. The panic virus, again.
Yes.
I reference that as very good documentation of that.
Yeah, that's in fact I mostly associate the anti-vaccine stuff with the left end of the spectrum, whereas the global warming denialism tends to happen more on the right. So each end has its own little anti-science.
By the way, as long as we're paused here, are you aware of the fact that Jenny McCarthy's contract with The View was not extended?
Yes.
She's off after a year.
Good.
She's out of view.
Excellent.
All right, so continuing with Joe's letter. Second, with respect to the Tamiflu review, a couple of thoughts. I would argue that Roche was fairly accurate in their marketing of the drug related to efficacy, in that I started listening to TWiV several years ago when, as a risk manager, I was trying to decide how seriously to take the H5N1 threat. Vincent et al. Convinced me at the time there was little value in stockpiling Tamiflu at a personal level due to the limited impact on symptoms and contagion. The new data seem pretty consistent with that past assessment, at least to the limited degree that I followed it. As a risk management professional, I object to the damning characterization of Roche as not having broken any laws as very unfair. I would state it as Roche tried their best to develop the most effective anti-flu drug they could in full compliance, as far as we know, with all the large number of conflicting laws and regulations that apply. They spent a lot of money on a risky discovery effort that apparently showed positive effects in the various models prior to human testing. I've not heard any evidence so far that they cheated or lied. It's fair to argue if the drug is good enough, but one can say with certainty that Tamiflu is better than all the drugs that their critics did not get around to inventing. Okay.
I think they ended up with something not very effective, and they wanted to sell it, right?
Yeah.
And they could because it got licensed and they could make their money back. So, I mean, yeah, I agree that nobody we don't see evidence for lying or cheating, but it's not a great drug, right?
Yeah, it's not a great drug, and I think the objection is that you shouldn't maybe you shouldn't be able to hype something that much on such questionable data.
Flu is it's a hotbed because people are scared and
Yes.
they want an antiviral, right?
Right.
It would be the same with Ebola. If you had a marginal antiviral, it would probably get licensed, right?
And stockpiled.
Yeah.
So, okay, continuing. Finally, it seems very reasonable to me that various countries decided to stockpile the drugs as a mitigation measure. If you put yourself in the place of manager in charge of deciding on national pandemic response measures, you're on the hot seat in the media and have politicians demanding a plan that they can get behind. The experts are able to give a very large list of things we don't know, and very few of them have enough data to prove the negative case that the threat is low. When you try to build a response plan, you're confronted by the glaring lack of any really effective options to protect your population. In that setting, even a drug with marginal effectiveness looks like a much better option than doing nothing. Planners did a lot of very good smaller improvements to our response plans related to coordination of service providers and communication to responders and the public. As someone who knows how hard it is to run a response, I was very happy to see those systemic improvements. Unfortunately, the folks in the media don't want to be bothered with those details. They want a home-run solution that will calm the public fears. Stockpiling some drugs just in case is an obvious, easy sell that might be career-ending to resist. And who knows, the drugs might turn out to be more effective on the pandemic strain. A more effective strategy for use might be discovered when the safety protocols are relaxed during a crisis. It might reduce fears in the middle of the pandemic. A key principle of risk management that we forget at our peril is that all risk decisions are made by humans with limited information in the moment. Personally, I think they made the right decision at the time, and I'm very glad we did not have to use them. As always, love the shows.
This is timely right now, right?
Yes.
Risk management with Ebola and antivirals.
Yep.
Not tested. I would be curious to hear Joe's take on that. I said before flu is a hotbed. That's not the word I'm looking for. When something is a focus of attention. What is the word? A sticking point or, Alan?
A flashpoint?
Flashpoint, right?
Good.
Influenza is a flashpoint.
Yeah.
Right. Thank you. All right.
And I think it's relevant to bring up in the context of this discussion again that after we've had a lot of discussion subsequent to our discussion of the Cochrane study, where we had a lot of input from physicians who their at least anecdotal and I think with a few numbers supported experience is that in cases where people are really sick, which is not what the clinical trials addressed, people where people are really sick, Tamiflu may have some benefit.
Mm-hmm.
Right.
Yep.
So.
Yep.
And I think we're going to see more about that over time when people have an opportunity, observational studies and et cetera, to see what it does in populations that wouldn't ordinarily be tested in a clinical trial.
Okay. Anything else before we move on? All right. John sends a cartoon from Condit Nast, which is really funny.
Yes.
Mrs. Robinson, are you trying to get me to listen to your podcast? It's a New Yorker cartoon. Very cute. Very cute. And we will put the link in and you can see what we're talking about. Rich, you're next, please.
Okay. Dear TWiV team, I only recently discovered your excellent podcast, and I'm already hooked. My fascination with viruses actually first started when I was 11 or 12 and doing some research for a school presentation. I thought their simplicity and elegance was absolutely amazing. I still remember searching for information about viruses on AOL and Ask Jeeves, the search engines of choice at the time. And most of what I learned came from the Encyclopedia Britannica and the CDC. Fast forward a couple of decades, and I came across your virology blog via your tour of the needle. I quickly became a regular reader and TWiV listener, and I am currently working my way through the Virology Part 1 lectures. I love listening to the episodes while I am traveling to and from work or in the kitchen, and I often wish I could pop by and join in the fun. Where do you live? You have an opportunity in
Yes.
Washington coming up. I have far too many questions, but today I will limit myself to therapies. 1. I recently came across the following article from Dr. Gregory Poland of the Mayo Clinic's Vaccine Research Group, which discusses the possible reemergence of measles as a serious health threat due to failures with the existing vaccine. For example, failure to develop protective antibody levels in some patients, as well as waning immunity over time, leading to previously immunized individuals later developing infection. Do you have comments on the effectiveness of the measles vaccine? Would it make sense to require previously vaccinated individuals to have a booster later on in life? Are you aware of other commonly used vaccines which have similar issues? You want to pause here and do this question?
Mm-hmm.
So, yeah, the measles vaccine is not as effective as we had once thought or hoped. Part of the reason that you see this is, you start using it in the context of measles being very prevalent, and then it declines down to a background level, and it's only when it gets down to that background level and beyond that you really get a very accurate picture of just how effective it is. And one of the things that's apparent, one of the ideas about what's going on as well, is that with this and some other vaccines, in the first few years that you use the vaccine, or your first few decades, people are getting naturally boosted by circulating wild-type virus. But you reach a point where the circulating wild-type virus is gone and you don't get that boosting effect anymore, and that's when the real effectiveness of the vaccine is revealed and you're liable to get some breakthrough. I know that measles boosters are actually required for people entering the University of Florida. Okay, so some boosting is recommended, but I don't know about a booster later in life. Sounds like it makes sense to me, but I don't know enough to really comment on that.
In 2013, there were 159 cases of measles reported in the U.S., and most of those were in people who weren't immunized. 65 in New York, 15 in California, 25 in Texas. So it's pretty good.
Yeah, it's pretty good.
Yeah.
Mumps is a little different because mumps were getting disease showing up in people who've had one or two vaccinations, and that's probably, again, the vaccine not being as effective as we had originally thought.
Pertussis is another one, which they switched to an acellular vaccine a number of years ago due to fewer side effects, but it's not as good, and there's some breakthrough, and there's some pertussis now in the U.S., there's some outbreak, so that may have to be fixed.
Well, they're already recommending Tdap boosters for anybody who has contact with or might have contact with kids.
Yeah,
which is
pretty much everybody.
Yeah.
And of course, as we have discussed several times before, the influenza vaccine is probably only about 60% effective in terms of actually preventing disease. But that's better than nothing.
Yeah, that's in a whole different category, I think.
Right. Okay. 2, secondly, I have been taking a course on the structure of DNA and came across a concept of DNA origami. One potential use of these geometric shapes created out of strands of DNA could be to enable targeted drug therapy within the body. And she gives, I'm sorry, is this he or she?
Simon.
Simon gives 2 links to that concept. Very cool, actually. As I have been learning more about viruses, it occurred to me that maybe a similar approach could be taken to removing virions from the body. That is, open cages that could snap shut like a mousetrap once they came into contact with a virion. Perhaps these cages could retain receptors specific to the virus they are meant to be targeting. I know that this sort of medical nanotechnology is a long way from becoming a reality, but I wondered if you could give me your thoughts on the potential for this type of post-infection approach. So basically, developing some sort of virus-specific mousetrap to.
That's not that far out. I'm blanking on most of the details of this, but I covered a talk where an approach kind of like that was used to trap. It wasn't viruses. I think it was autoimmune cells from bloodstream, and it was essentially a lobster trap baited with the antigen, and they managed, at least in an animal model, to sop up the autoimmune cells that were causing the problem in this model. And I don't know where that stands now. And as I say, I'm sorry, I'm blanking on the details, but it's a concept that at least at that level has people have been thinking about.
So is the idea here that you would make a DNA that would bind a virion and attach it to a nanoparticle of some
I think
kind?
that's what he's getting at.
I mean, that can be done, right? You can get nucleic acids to bind proteins. And
good point.
right?
Aptamers, yes.
Aptamers,
Right.
yeah. So I would guess you could do it. Yeah, I don't see why not. But I don't. Then I guess you depend on your reticuloendothelial system for clearing the bound viruses, right?
Yeah, and
Sure.
I mean, you'd have to justify doing something that exotic. It would have to be more effective for some reason than say a monoclonal antibody.
Yeah, I mean, injecting these things could be. I mean, that would be how you would use them, I presume, right?
Sure.
Intravenously, they'd have to be able to diffuse into tissues and have no side effects or few. But it's an interesting idea. I think you ought to work on it.
Yes.
And he winds up, thank you so much for the work you're doing and providing these excellent resources on such an interesting topic. Keep up the great work.
Great. I'm glad you discovered TWiV, Simon, and you should recommend it to 10 more people. Okay, one more. From Michelle, fan feedback. Hello, TWivers. I've been following the TWiV podcast for the past year, and I am an ever-growing fan of your work. I love the depth of each discussion as well as the variety of topics covered in each episode. 1 year ago, I finished my doctorate of veterinary medicine and immediately started a PhD in veterinary pathobiology virology. My virus of focus is African swine fever, the only known DNA arbovirus and sole member of the family Asfarviridae, though I'll bet you already knew that. It's okay, we like hearing it. Having gone from only a basic understanding to a currently deeper yet ever-growing understanding of virology this past year, I've really enjoyed learning through your podcasts. I started out having to look almost everything up that you guys discuss, now to completely understanding about 85% of the material covered. Still learning, though. I often listen to your podcast while running, but sometimes that proves difficult because I want to write notes on things to look up later. Thanks again for the great content and keep up the good work from Geelong, Victoria, Australia, and Manhattan, Kansas. Now, I was just in Geelong, Michelle. And if you're in Geelong, you must be at the Australian Animal Health Research Laboratory, which is where I visited. So why didn't you come say hello? You probably didn't know I was there.
Maybe she was in Manhattan, Kansas.
Yeah, maybe.
Yeah. She says she finished her doctorate a year ago. So,
I have to look everything up too, Michelle. I can't remember. Yeah. I don't, we all do. We just know where to look. That's the key, right? Yep. All right. Let us do some picks of the week. Man, look at all these email.
Yeah.
It's crazy.
Does your document take a long time to scroll? It's kind of laggy.
I'm okay.
You're okay?
Mine was having a problem earlier, and so I rebooted. But
I just did keyboard shortcut end to page and then scrolled backward because it's a lot quicker than scrolling through all the emails.
What's the keyboard shortcut for page?
Command down arrow.
And I have this thing called page down.
Oh, does page down work?
It just goes a page at a time.
Oh, it just goes a page at a time, yes.
All right, Alan, what do you have for us?
I picked this blog a while ago as a pick, and now it is coming out as a book. This is WTF Evolution, a theory of unintelligible design. And this is going to be a coffee table book. I think it's coming out beginning of October, so in time for the Christmas season. And you can get somebody this book of material that's based on these sort of train wrecks of evolutionary biology that have been featured on the blog.
Could we make a coffee table TWiV?
We probably could.
How would that be? Like, it's not going to be a book, though, right?
Yeah.
Something that you just push a button and it would play episodes.
I think that's called an iPod. Somebody beat us to it already.
But just on your coffee table, you know.
Yeah.
I want to be a coffee table. Hey, that's cool. Nice. Kathy, what do you have?
By the way, I just bought it.
You just bought it?
Yeah. Actually, it's not actually available.
You pre-ordered it.
I pre-ordered it. This
It's
needs
not
to go on my coffee table.
It's not that expensive. It's not like a Lamborghini.
No, it's $10.
No, it's $10.
All right. Kathy, what do you have?
I picked something that I'm thinking maybe somebody picked before, but I decided I'd pick it again in any case. It's called Inside Insides, and it's a whole bunch of videos of MRIs of plants and food and things, and they're really cool. Did you pick this?
I picked something similar to this. I don't
think it was the same.
I don't think it was the same thing.
I used the search tool on the TWiV page as best I could, and so there's a search box on the page, and I recommend broccoli and pink mink protea because they both look like fireworks. Also, some favorites are artichoke, Brussels sprouts, jackfruit, kohlrabi. Anyway, there's just a lot of these, and they're not always just MRI. I think he uses some other imaging techniques as well.
You know, knowing how expensive it is to do an MRI, I'm surprised that they're doing it on this kind of stuff. Unless they
this is a lab research on the About page. He explains he's a technician in a research MRI, and I guess he's just using, and the machine's not occupied 24/7, so he's just putting these in when nothing else is in there.
So the first patient the next morning comes in and sees a broccoli line.
Well, no, it's a research MRI.
That's not for people. Good. It's at BU.
Yeah.
Cool.
The hospital MRIs are busy 24/7.
Yes, or they try to be. Yeah. Because those are
might be at 3 a.m. or something. Yeah.
major resource.
Rich, what do you have?
I just ran across this the other day. It is the Cold Spring Harbor Laboratory Oral History Collection. So this is a link to Cold Spring Harbor where they've posted interviews with a lot of different scientists who've either worked at Cold Spring Harbor over the years or have been regulars there. So there are quite a large number of familiar faces talking on all sorts of topics, like how they became a scientist and what their lives are like and everything else. So it's pretty interesting.
What is this? Is this a recording type thing or what?
Yeah, they're little videos.
And for any one person, there's a whole series of short little links, and you can.
Oh, I see.
So just pick what you want, and as soon as you start playing one, the transcript comes up as well.
Yeah,
so if you decide you just want to hear the person for a little bit and then scan the transcript, you can do that.
So you want to
hear what Renato Del Becco had to say about Jim Watson, you can skip directly to that.
Right.
Or pretty much what anybody at Cold Spring Harbor had to say about Jim Watson. They all have remembered.
They got a bunch of great stuff here. Fred Sanger, you know?
I think we should do this.
Advice to young scientists from Fred Sanger.
Should we do this for TWiV? Can have people, the transcript show up next to it, or you can click and go wherever you want.
Somebody's going to do it,
With our grant.
Pay somebody to do it.
Yeah.
Hey, guys, I'm looking at Ann Skalka here, who I know she's a co-author on my textbook, and I did a TWiV with her a couple of weeks ago with Glenn Rawl. It's a little different. It's not just a person sitting there, you know. This is a different. But anyway, it's cool. All right, I have a neat pick, which is called Going Viral. It is by the Rocky Mountain Ballet Theater. This was given to me by Marshall Bloom, who works at the Rocky Mountain Laboratory over in Hamilton, where I visited this past summer. It's a series of collaborative works between the ballet theater and the choreographer Charlene Campbell. And it's essentially inspired by electron microscope images. And they have a dance. It's a ballet for different viruses. They have one for polio, influenza, Ebola, and dengue, And they're basically, ballets, and they're set in front of a screen, and you can see images coming up on the screen, lots of electron micrographs. The polio one is cool. It begins with just a wheelchair on the stage, and people come out and dance. So check it out. It's neat.
Yeah.
This is neat.
It's a little combination of art and science there.
Yeah, as you keep scrolling down the page, then eventually you get to the videos to start playing.
Yeah,
okay.
they're way down on the page there. And, of course, there are lots of virologists out there in the Rocky Mountain Lab, and they helped with this. They gave advice and so forth and images.
There's a video here introduced by Marshall Bloom.
Yes, so there's Marshall who turned me on to this. So it's pretty cool. And actually, the TWiV that I recorded there will come up next Sunday.
Cool.
We're not going to be doing one, so a little preview of Rocky Mountain Lab. It's a pretty cool place.
One of these ballets is about Ebola.
Yeah.
Yep. They didn't do norovirus.
Great.
Yes.
Yeah. Not
Yeah,
surprised.
these are really good. This is neat.
I have a couple of listener picks. One is from Kim. I would like to give a pick of the week. I recently noticed that NobelPrize.org has started uploading podcasts both on their website and on iTunes. These podcasts are interviews with Nobel laureates, very similar to the kinds you do sometimes with specific researchers. Thus, you are probably happy that someone else is helping you collect interviews with important researchers onto the web. So she gives a link, or he gives a link to that. I highly recommend episode 25 with Tim Hunt. So thank you, Kim. Johnny, our pediatrician friend in Cambridge, something that probably is not a suitable pick, but at about 6 minutes, George Carlin offers his thoughts on why there are viruses. Who knew? Warning, this link contains adult, mature language not suitable for young, tender, innocent ears.
That's redundant. You said George Carlin.
Yeah.
So she gives us the link on YouTube. It's pretty funny. Yes, not suitable. This is a clean podcast. And the last is from Jenny. Dear TWiV team, given the TWiV story arc of zombies and the occasional confusion about the nature of a zombie threat expressed by some hosts, I thought you might want to see the U.S. Strategic Command's counter-zombie dominance plan. She provides a link to a PDF file for this plan, which is a very official document, as you will see. The plan to preserve non-zombie humans from the threats posed by a zombie horde includes a number of measures related to the potential infectious origin of zombies, and she's quoting now, pathogenic zombies are zombie life forms created after an organism is infected by a virus or bacteria or some other form of contagion. That's page 6. There is no known medical cure for a zombie pathogen. At this time, it can be assumed that once a human turns, they cannot be cured or reverted to human status. Seek out the nearest CDC for any hopes of medical breakthroughs during a time of pandemic. There may be times when individual healthy humans will be forced to abandon other IHHs who are unable to evade sources of zombie contamination. Such situations could arise while IHHs are evacuating in the face of incoming zombie forces. IHHs must not be allowed to go back for family, friends, or other personnel who cannot get away from zombies quickly enough. Back to Jenny. Of course, a disclaimer on the plan states that members of a U.S. Stratcom component found out by accident that the hyperbole involved in writing a zombie survival plan actually provided a very useful and effective training tool. We elected to use a completely impossible scenario that could never be mistaken as a real plan. Or is it? Enjoy.
And I should remind people that CDC actually has a page on zombie preparedness.
Yes. For which they received some award, I think, some time ago. So thank you, Jenny. And that'll do it for TWiV 298, which you'll be able to find on iTunes and also at twiv.tv. And if you want to send us a question or comment, we'll get to it. We steadily, slowly but surely, like a tortoise, we get to them, even if it's late, because we do read just about all of them. So send them to twiv at twiv.tv.
We ought to have like a marathon thing where, some Saturday.
24 hours of TWiV.
Yeah, 24
The letters
TWiV.
episode.
We're going to get through all this email.
Like a filibuster.
I don't mind. I don't know how people like the old all email episodes. In Australia, somebody told me they don't like them and they skip the old email episodes. But that was just one person,
I've heard it both ways.
I guess
Some people
There's a lot
really
of
like
variety.
them.
Yeah.
that's why we haven't done one.
We can
lately.
take an audience poll in D.C.
Yeah, so that will be our next episode that we record together at number 300 in Washington, D.C., and you can find the details on the website.
And you better get tickets fast.
You better. They're free, but you have to register. Kathy Spindler is at the University of Michigan in Ann Arbor. Thank you, Kathy.
Thanks. This is fun. As always, I learned a lot.
Rich Condit is in the land of libraries, the University of Florida, Gainesville. Thank you, Rich.
Always a good time. Thanks. This is good fun.
And Alan Dove is at turbidplaque.com. You can also find him on Twitter. Thank you, Alan.
Always a pleasure.
I'm Vincent Racaniello, and you can find me at virology.ws. You've been listening to This Week in Virology. Thanks for joining us. We'll be back next week. Another TWiV is viral.